morning. This little video is about the Ossur cold brush system. Many systems are like it. Basically, it's a cooler, a rheostat to control the pump output, a pump, supply lines, and then some connectors to a specific pad. So this is a picture of it. You can look it up. What I'm going to show you today voids your warranty, probably voids everything. I'm not guaranteeing it's going to work, but in my case, um, I'm pretty handy, and this was the issue. So looking at the unit here, right where the cursor is, on each handle on each side is a plastic decal. You need to remove that, remove each Phillips head screw, put that away. That's the first step. Obviously, you want to drain it before and remove the power supply. That way you don't have an electrocution issue. So you remove the screw here, remove the screw there, that'll come out, and there's a bar that fits inside. Upside down, there are numerous screws, all Phillips, and they basically hold the water tank in the cooler, which I'll show you. Here's your supply lines. Here's the connection to your output pad, as I'll call it. This is just a little on-off switch, and then the pump control rheostat. This is a simple plug-in power supply. And again, you never plug it in unless you're ready to use it. Decrease the chances of issues with water and electric. So let's go forward here. I didn't find much help on the web, and once I figured this particular problem out, I figured, hey, why not share it? So here we go. So when I turned, a friend of mine loaned me this. I needed it, and let's just figure my inflammation in my left leg has lasted about a week after some surgery, kind of major surgery. And, you know, by recording the surface temperature with a laser thermometer, it's really interesting that my left leg runs about 6 degrees warmer than my right. So these pads really can help, and they'll last a lot longer than your gel pad. But anyway, so there's the background. So a friend gave it to me, and lo and behold, it came home, and the book said to run, you know, some 3% hydrogen peroxide through, make sure everything's clean. And when I turned it on, good thing it was in the kitchen, pump was running, and it was just pushing water. And of course, water was all over the floor. And the reason for that, well, I'm showing you here. Inside the two supply lines, they are insulated. So inside there, for whatever reason, they used a nylon higher pressure tubing. And as you can see here, it just disintegrated. I don't know if it's because of 5 years, a reaction to maybe chlorine, if people use chlorine to clean. I'm not really sure. But anyway, the problem was obvious. Supply lines were shot. So the next thing was to take it apart and, you know, see how I could put this together, simply cheap parts. All right. So after you get that handle out, and you've removed these screws here, which is the top half. They go here to your bin that holds the ice and water. Right here is the pump. You'll notice their tubing they use is PVC vinyl. They didn't use the nylon in there. And like I say, it's just a simple pump. And the pump's working great. What I did was able to salvage the connections by putting them in hot water to release the glue set. Down here is your rheostat control, and these are your output pipes. So basically I have to run new supply lines in here, connect them, and then put it all back together. It wasn't that difficult. So here we're looking underneath the bottom. You can see there were some screw attachments that go through the bottom half of the cover. Here we're looking at the pump, and you know, just my little favorite mug here. But that's just hot boiling water, and you soak the connections so they come out easier. This is showing you the inside of the actual supply line that was inside the insulator. You need to have it insulated because it gets cold and it condensates. Anyway, so inside in my test, you know, here again is broken right from the pump, and this is how they had it connected. So it's basically using a standard barb connection, glue, and then a wire tie. So my idea was to, you know, save as much connection as I could and replace it with this 1/4-inch inside diameter tubing, which can handle a max of 75 psi pressure, but a continuous of 55 psi. And we don't know what the psi is on this, but it's definitely been tested and does not leak, so it doesn't come close to that amount of pressure. Anyway, you can see that there. So this is just testing the connectors. There's special connectors that go from the supply line to your pad. Here I'm just making sure they're going to work with some sample tubing I had. You can see they did use clear tubing, but the outside was just the disintegrated supply line. Here's showing you a little test. You can see the ice back in the bucket. I'm probably going to replace these with some stainless steel, regular hose clamps. I did use stainless steel inside the unit just to limit any uh, reasons for leakage. But anyway, after I did this, a couple things you can do. It'll use about 5 pounds of ice. You could use, say, 2 pounds of ice, and then throw in some frozen water bottles or frozen gel packs. But with full ice load and full temp, you can get about 4 to 6 hours out of it. And again, it's with these extra compression pads works really well. So again, for about $10 and maybe an hour's time, I was able to disassemble, fix, replace. And what I did here was I just cut the outer insulation and then reused it with tape, as you see here. I didn't, make it look pretty, but I made it functional, and that's really what mattered to me. So I've used it every day for a week, at least 10 hours a day, and it is not leaking. So I know this is a good fix. Anyway, enjoy. Go ahead and share, and adds a nice little extra gear at home for when you need some good icing.